Kia ora, here's question 2E from this year's Level 2 Algebra exam. So it's worth reading through pretty slowly before we get going with this one. We've got two simultaneous equations and we've got x and y as usual, but they're not like year 10 simultaneous equations where we've just got linear combinations. We've got an x squared here plus a 2ky is equal to 6k. So I guess what jumps out at me is that we can turn this into a quadratic in x if we start with this first one and we rearrange. So we've got y minus 2x equals 13. We can rewrite that as y equals 2x plus 13. And then we can take that and we can substitute it in here. That's going to give us a quadratic. And we're told that there is only one solution to the equations. So find the value of k. So it's kind of screaming, this is a discriminant problem to me. And then we have to find the solution to these simultaneous equations. Now, just before we get going, we're also told that k is a constant, so it's not a variable. K is a non-zero constant. So we're going to ignore k as a solution if that ends up being one of them. All right, let's get going on it. So pause the video and have a go on your own. I've given you a pretty big hint to get started. So y minus 2x equals 13 means that y equals 2x plus 13. And in my second equation, we have x squared plus 2ky is equal to 6k. So x squared plus 2k times 2x plus 13 is equal to 6k. Cleaning that up gives me x squared plus 4kx plus 26k minus 6k. And that equals 0. So x squared plus 4kx plus 20k is equal to 0. So one solution means that the discriminant of that, which is b squared minus 4ac, has to be equal to 0. So what we're going to be drawing is a parabola, an up the right way parabola, and it's going to be sitting here or here or here or somewhere along the axis. And that's one way that we can check at the end, is to make sure that that all fits together. I'll just get rid of that bad graph and we'll get into the algebra. Okay, so A is 1, B is 4k, and C is 20k. That gives us b squared minus 4ac is equal to 4k all squared minus 4 times 1 times 20k, giving us 16k squared minus 80k. And we have to have that equal to 0. We can factorise that as 16k times k minus 5 is equal to 0, giving us two solutions. K is equal to 0 or k is equal to 5. But we know that k can't be equal to 0. So k is equal to 5 is our solution. Now we need to go back to the question and check what do we need to do from here. We definitely should be checking it. Find the solution to these simultaneous equations. Okay, so what we have to do now is we should end up with an x value and a y value. So we'll substitute 5 back in and we get y minus 2x is equal to 13 and x squared plus 10y is equal to 30. So rewriting this gives me x squared plus 10 times 13 plus 2x equals 30. Right, this is a little bit repetitive. We could have done that a slightly faster way. We get x squared plus 20x. I get 130 here, take away 30 here, so plus 100 equals 0. That gives me x plus 10 squared is equal to 0, giving us an x coordinate of negative 10, and y was equal to 13 plus 2x, which is 13 minus 20. So y has to equal negative 7. Okay, so solving all of that, what do we end up with? Yeah, so the value of k is the first thing that we found. So k is 5, and then the solution to the simultaneous equations is an x, y value of -10. And what was the other number? Well, we have -7. Yep. Okay, there's quite a bit in there, and it'll be interesting to see how where the marks are given. I'm guessing probably it's a merit to get to here, and maybe it's the T tick to get to here. But it's too soon to see the schedules. So there you go. I'll do question 3 later on.